Hello guys, welcome back to Trends and Facts, your cozy corner for fascinating stories about our world and beyond. Today, we're diving into one of the biggest questions ever asked. How did the universe start? We'll travel from nothing to the first twinkling stars, and I promise to keep it simple, fun, and friendly. So grab a snack, make yourself comfy, and let's blast off into the story of everything. Before we start, let's be clear. When we say universe, we mean all of space, time, matter, and energy. Everything you see, touch, sense, and even what you don't see, like invisible particles. Imagine blowing up a balloon. The balloon's surface is like our universe. It has no edge, it just keeps stretching. Inside that balloon, you have dots. Those are galaxies, stars, and planets. You might ask, what was there before the universe? Honestly, that's a tough question. Scientists call it a mystery. Some ideas say there was nothing. No space, no time, no matter. Other ideas suggest maybe our universe was one in a long line of universes that expand and shrink again and again. But here's the key. We don't yet have a clear answer. And that's part of the fun. Science is still searching. About 13.8 billion years ago, something incredible happened. We call it the Big Bang. But don't picture a bomb going off. There was no there outside the explosion. Instead, space itself spread out. Think of drawing a dot on a balloon and then blowing it up. The dot stays, but the space around it grows. At the very start, all of space grew super fast in a tiny fraction of a second. This extra fast growth is called inflation. Inflation was like blowing up that balloon not just a little, but going from a pinprick to a big beach ball in the blink of an eye. In less than a trillionth of a second, the universe doubled its size over and over. Why did it happen? We have theories. Some say it's a field of energy that pushed space apart. After inflation, the universe kept growing, but at a slower, steadier pace. Right after that super quick growth, the universe was wildly hot, millions of times hotter than the center of our sun. It was also incredibly dense, like all the stuff in a mountain squeezed into your pinky nail. As space stretched out, it cooled down a bit. When it cooled just enough, tiny particles could form. First came quarks, the building blocks of protons and neutrons and electrons. Then quarks paired up to make protons and neutrons. According to the Big Bang theory, this extreme heat and density came from that very first expansion of space and time. As it continued to grow, everything began to cool, and that cooling set the stage for the first atoms. Fast forward a few minutes, around 3 minutes after the Big Bang, and the universe cooled to about 1 billion degrees Celsius. Protons and neutrons started sticking together to form the nuclei of hydrogen and helium atoms. But it was still too hot for electrons to stick to these nuclei. So the universe was filled with a glowing, foggy gas of atomic nuclei and free electrons. This fog meant light couldn't travel far without bumping into electrons. Jump ahead to about 380,000 years after the Big Bang. The universe cooled down to roughly 3,000 degrees Celsius, still hot, but cool enough for electrons to join nuclei and create neutral atoms. Suddenly, the universe became transparent. Light could finally travel freely. That light is still traveling today, stretched out by the expanding universe. We detect it as the cosmic microwave background, or CMB, a gentle glow filling the sky. It's like the baby picture of our universe. Scientists study tiny variations in the CMB's brightness to learn about the universe's earliest moments. After the CMB was released, there were no stars or galaxies, just a dark, cool universe of neutral atoms. This period, lasting about 100 million to 200 million years, is called the Cosmic Dark Ages. Gravity was quietly doing its work, pulling matter together into clumps. but nothing was hot enough or dense enough yet to ignite stars. Around 100–200 million years old, the first stars burst to life. These were called population III stars. They were huge, maybe hundreds of times the mass of our sun, and burned very hot and bright. Their intense light and heat began to reionize the surrounding gas, meaning it stripped electrons from atoms again. This process, called the epoch of reionization, cleared the cosmic fog so that space became transparent to ultraviolet light. As more stars formed, they grouped together in clumps of gravity into the first galaxies. Small galaxies merged into larger ones, cosmic Lego building. Over billions of years, these structures grew into the vast galaxy clusters and superclusters we see today. Our own Milky Way galaxy formed about 13.5 billion years ago, not long after the first stars. Inside it, our Sun and Earth would form much later, about 4.6 billion years ago. But wait, there's more we can't see. Dark matter and dark energy make up about 95% of the universe. Dark matter, it doesn't emit light. We know it's there because its gravity helps hold galaxies together. Dark energy, it pushes space apart, making the universe's expansion speed up. We're still on the hunt to understand these mysterious ingredients. They shape the universe's fate, but remain hidden from direct view. In the 1920s, astronomer Edwin Hubble found that distant galaxies are moving away from us, and the farther they are, the faster they move. He measured this by looking at the redshift of light, stretching of light waves toward the red end of the spectrum. This was the first clear proof that the universe is expanding. So every galaxy sees other galaxies speeding away, just like raisins in a loaf of rising bread. So far, we've seen the universe grow and change, but what about its future? Scientists consider a few scenarios. Big freeze, expansion continues forever. Stars burn out, the universe cools and goes dark. Big rip, dark energy's push gets stronger and stronger, eventually tearing galaxies, stars, and even atoms apart. Big crunch, gravity wins. Expansion slows, reverses, and the universe collapses back to a hot, dense state, maybe starting a new Big Bang. Right now, evidence points to accelerated expansion, so the big freeze or big rip seems more likely. But remember, science can surprise us. You might wonder, why should I care? Well, we are made of stardust, elements created in stars. The story of the universe is our story. By learning how the cosmos began, we learn about the laws of nature, the building blocks of matter, and the origin of life's raw ingredients. It tells us where we came from, and maybe even where we're headed. And that's how our universe went from almost nothing to the vast, star-filled place we call home. Thank you for coming on this cosmic ride with Trends and Facts. If you enjoyed our adventure, please like, share, and subscribe, and hit the bell icon so you never miss out on our next journey into the mysteries of science and history.